Hello friends, my topic is problem based on binomial distribution and Poisson distribution. Before going into the problem, first we discuss the basic definition of binomial distribution. It is a discrete probability distribution that describes the number of success in a fixed number of independent trial of binary experiments where each trial has only two possible outcomes, either success or a failure. The formula for the binomial distribution is P of r equal to NCR P power r Q power n minus r, where n is the total number of trials, P is the probability of success, Q is the probability of failure, where Q equal to 1 minus P, r is the number of success in n trials, n minus r is the number of failures in n trials. These are the basic part. We moving into the problem. Our question is a perfect cubic die is thrown a large number of times in a set of 8. The occurrence of a 5 or a 6 is called the success. In what propagation of the set would you expect 3 success? From that question we understand that there are two possible success outcomes. One is 5 and another one is 6. Therefore the total number of success is 2 and the total number of phases in a die is 6. Therefore P equal to total number of success divided by number of phases in a die. So 2 by 6 equal to 1 by 3. But Q equal to 1 minus P, we substitute the value of P in that equation. So 1 minus 1 by 3 equal to 2 by 3. And N is the total number of trials, which is 8. We substitute these three values in that equation. P of r equal to NCR P power r Q power n minus r. Substitute these three values in that equation, we get 8 into 7 into 32 divided by 81 into 81. After simplify that equation, we get 0.273. Here we use 100 sets in the problem to estimate how often we would observe exactly 3 success in a practical scenario. So that only we use that 100 sets. The probability of 3 success in a 100 set is 27.31%. This is all about that binomial distribution problem. We move on to the Poisson distribution problem. Before moving into the problem, we will discuss the basic definition of the Poisson distribution. It is a discrete probability distribution that represents the number of events occurring in a fixed interval of time or phase given a known average rate of occurrence. The event must be independent and occur at a constant average value. The basic formula for the Poisson distribution is PR equal to e power minus lambda into lambda power r divided by r factorial. Here r is the number of event in a unit of time, space and volume, where lambda is the mean value, e is the base of natural logarithms and is approximately equal to 2.71828. Problem is earthquake occur in the western United States with a rate of 2 per week. If we model the number of earthquake as a Poisson random variable, what is the probability that there will be at least 3 earthquake in a 2-week period? Here we given that earthquake in the western United States occur at an average rate of 2 per week. The number of earthquake follows the Poisson distribution is that occurrence of rare event in a fixed time period. Here our thing is to calculate the probability of at least 3 earthquake occur in a 2-week period. Let L be the number of earthquake in 2-week period. Here lambda is the mean value. Therefore 2 into 2-week per period. So that 2 into 2 which is equal to 4. We substitute that lambda value in that formula, which is PR equal to e power minus lambda power r divided by r factorial. So here r is considered to be as x. So P of x equal to 4 power x e power minus 4 divided by x factorial. So now we find the probability that there are at least 3 earthquakes in a 2-week period. So P of x greater than or equal to 3, which equal to 1 minus P of x less than 3. Therefore 1 minus P of less than 3, which is equal to P of x of 0, P of x of 1, P of x of 2. After substituting the value of 0, 1 and 2 in that equation, we get 1 minus 4 power 0 e power minus 4 divided by 0 factorial plus 4 power 1 e power minus 4 divided by 1 factorial plus 4 power 2 e power minus 4 divided by 2 factorial. After equating and when calculating those values in that equation, we get 1 minus 13 into e power minus 4. After calculating this value, we get 0.7619 as the probability of at least 3 earthquake in a 2-week period. Our next problem is that find the probability that at most 5 defective fuses will be found in a box of 200 fuses if experiences show that 2% of such fuses are defective. From that problem, we need to find that probability that at most 5 defective fuses are found in a boxes of 500 fuses when it is known that 2% of that such fuses are defective. From the problem, we taken the total number of fuses n equal to 200 and the probability of fuse being defective, which is q equal to 2 by 100, which is equal to 0.02, and lambda is the mean value, which is equal to n into q, where n is 200 and q is 0.02. So 200 into 0.02, which gives 4. We substitute lambda values in the equation. PR equal to e power minus lambda into lambda per r divided by r factorial. So that here also r is considered to be as x. So p of x equal to 4 per r into e power minus 4 divided by x factorial. Same like that before problem, here also we find that probability of each defective fuses, that is p of 0, p of 1, p of 2, p of 3, p of 4 and p of 5. So we substitute in that place of x in 0, therefore e power 4 into 4 power 0 divided by 0 factorial. Here 0 factorial is 1, so e power 4 equal to 0.0183. Same like that, p of 1, p of 2, p of 3 and p of 4 are done. After calculating these values, we substitute that each 5 values in that equation. So the probability that at most 5 defective fuses are found in a box of 200 fuses is p of x less than or equal to 5. Why we use here less than or equal to, means here the defective product only we have to find, so that only we use that less than or equal to 5. So equal to p of 0 plus p of 1 plus p of 2 plus p of 3 plus p of 4 plus p of 5, which gives, after substituting these values, we add that whole thing, we get 0. Therefore, the probability that at most 5 defective fuses are found in a box of 200 fuses is approximately equal to 78.5%. Thank you.